So we're actually going to start with trying to sketch a rational function when it's not in the form of 1 over x, or we can do transformations on. But the first thing I want to talk to you about is an idea called discontinuity, or continuity of a function. For as far as continuity of a function goes, the best way to think about it is whenever you're drawing a graph. So let's use a line as an example. Whenever I draw a line, I never have to pick my pencil or pen or whatever I'm writing with up. That means it's continuous, because a good way to think about it is I don't have to pick up my hand as I'm drawing it. But there are times where we're going to graph something like this. This is the graph of 1 over x. So 1 over x. So I drew this part, but then I have to pick my hand up to draw this part. So there's actually what we call some discontinuity here. The discontinuities we look at are vertical asymptotes, holes, or what's also called removable discontinuity. And then we also are going to look at end behaviors of graphs. Now, in the next class after pre-calculus, in calculus, you'll study continuity in a much deeper level, because there are actually three requirements for a function to be continuous. The first one is that f of c must exist. So C, we're going to call C, is an element of the real numbers. That basically means if I plug any number in there, it actually has to exist. My second requirement, and this part is going to be a limit. The limit as x approaches C of my function x has to exist. And then the third requirement is that f of c has to equal the limit as x approaches c of f of x. Well, this you're going to study more in calculus when you actually get there. So what does that mean for us in pre-cal? Well, what that means for us in pre-cal is you're going to see a lot of limit notation as we're going through this, and we're going to have to be plugging some numbers in as well to evaluate. So we're really working on these two from that aspect. Now, we are going to be dealing with discontinuities, so either one of these two are not going to exist or this one's not going to exist. But I'm not going to actually ask you to do this because this is the actual calculus part of this. So let's just kind of jump in and see how this works out. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.